Alright, here we go. We got absolute value functions that we're going to be graphing a lot today, and then looking at some of the attributes. Okay, so you can kind of go through all this. It kind of gets a little wordy here, but here's what absolute value functions look like. They look like these little V's here. If you were to make a table here, which is what I'm going to do here to show out this first example here, the absolute value of x, we're going to graph a few points here to see where the shape comes from. So if you do that here, we can do numbers like -2, -1, 0, 1, and 2. Now if we think about this here, the absolute value of -2 should output us +2 right there. Okay, the absolute value of -1 should get us +1 as well. Absolute value of 0 is going to be 0. The absolute value of +1 stays as +1, and the absolute value of +2 stays as +2. And that's where some of these some of these first few points right there come from there. So it makes a sharp V look to it right there, and it keeps going up and left forever right there. So that is the parent function right there. Let's see if they, yeah, here it is right there. So that would be something good to circle or highlight right there. That is your parent absolute value function there. And when we say a parent function, usually that's like a simple version of like a type of function. Like you have like lines, straight lines, y equals x is your parent function. Or like quadratics, like your U-shaped graphs, the parent function is y equals x squared, like the most basic, simple one. Okay, the parent function for the family of all absolute value functions is this right here, like we just said. It's symmetric about the y-axis, so that means the y-axis cuts the graph into two equal parts, and it's the same exact thing. It's like it's mirrored across the y-axis there. That means for every point x comma y on the graph, they got this fancy thing here, -x comma y is also on the graph. The highest and lowest point of the graph is called the vertex right there. The vertex of the parent function is 0, 0. Okay, so then for these first couple of examples here, we're actually going to look at what happens when you start messing around with the different numbers. And today we're going to kind of focus on making a table for these, but then tomorrow we kind of get into some of the rules here, and we might even touch on it today a little bit, but some of the different rules and what the different numbers actually do to the parent function of the graph to make the graphing a lot easier here. But let's stick with tables for right now here. So I'm going to make a little x and y table here, and then here in the middle I'm going to put all my work. So I'll just kind of write it out here. So a couple of points that we're going to do here, I kind of know what the graph is going to look like here. So I'm going to do -1, 0, 1, 2, and I guess 3 right here. So we're going to plug all of those numbers into this absolute value function. So if we do, like, for example, -1 minus 1 inside the bars, then minus another 1, it's kind of a lot going on there. -1 minus 1 right here in the middle is -2. Absolute value of -2 is +2, and +2 minus 1 is 1 right there. So sometimes you might, need to write, go off to the side and write out a few steps right there, but apparently that's the point there, -1 comma 1. Okay, now another point, if we plug it in here, 0 minus 1 right there, and then minus another 1. No, maybe I should make my ones kind of like this here so you guys kind of see the difference between that and the bars. Okay, but anyway, 0 minus 1 right there, that's -1. The absolute value of -1 is going to be +1, and then 1 minus 1 is going to get us 0 right there. Okay, let's do another one here. So absolute value, let's go 1 minus 1, and minus another 1. A lot of 1's going on right here. 1 minus 1 inside the bars, that's 0, and then 0 minus 1 is actually -1. Okay, now same thing here, we'll go and do 2, 2 minus 1, and then subtract off a 1 from that. There, so 2 minus 1, I know that doesn't look the best. Let's see if I can make that look a little bit better. 2, there you go, 2 minus 1 right there is 1, and 1 minus 1 is 0 again. And then last but not least, 3 minus 1. Okay, and then so that'll be 2. 2 minus 1 is 1 right there. And then now we're going to go plot all these points here. So this first one here is -1, comma 1. So let's go plot that. Back 1, up 1, there's your point. Next one was 0, 0. Next one was 1, comma -1. Next one after that was 2, comma 0. So there's that vertex right there. There's that V portion. And then the last one was 3, comma 1. And it will keep doing that forever. So we can draw a little arrow. It's going to keep doing that to pattern for a while there. That's what your graph looks like. Alright, and what else do we need to do here? Graph using the table, analyze the domain, the range, the intercept, symmetry of the graph. Alright, so domain for these. Domain's pretty nice. It's going left and right forever. It's because of those arrows. So we're going to say the domain is from -infinity to +infinity. Okay. Next, we got range. Now the range, these are going to be different every single time here. Range is kind of based off of your vertex right there. If you know where your vertex is, the range is pretty easy. So range is how far up and down. Now the range, it keeps going up forever, but it ends there at that point right there, I guess at -1. So we're going to say the range goes from -1 all the way, and actually I need to put something here. We'll put a bracket around this because we're including -1. So from -1, and then it goes up forever. So we're going to say towards infinity. So starting at -1, going up forever. Okay. What else we got? Intercepts. Okay, so x-intercept, and actually, so the x-intercepts are two different ones right there. So you got 0, comma 0, and you also have 2, comma 0. Now, as far as a y-intercept and as far as where it crosses the y-axis, there's only one. Crosses at 0, comma 0. And then the symmetry of the graph, you can say, we call this the axis of symmetry a lot in math. So the axis of symmetry is going to be this line right here, this little dotted line that I'm drawing right there. And that goes through 1 right there. So we're going to say the axis of symmetry goes to the x value, +1. Right there. And that is all your stuff there. Sometimes they'll ask about the vertex. I don't know if they actually said that here, but let's go ahead and add that in. The vertex is going to be at 1, comma -1. Right there. And that is all of your different things that you need for your graphs. Okay. Now, the next one here, kind of the same idea. So we'll go, let's see, x, y. Make a big table here, and I'm going to start this one at 0, 1, 2, 3, and 4, because I already kind of know what the graph is going to look like. And yeah, we're going to set that up here. So we got 0, -2 for our first set, and then we're going to add 1 to that. So that'd be +2 inside the bars, and then +2 plus 1 will be 3. Okay, next one here, we're going to go 1 -2, and then +1. So that'll get us -1 inside the bars. That'll turn to positive, so that'll be +1 plus 1, that'll be 2. Okay, we're going to go 2 -2 inside the bars, which will get us 0. 0 plus 1 should be 1. We're going to go 3 -2 inside the bars, which will get us 1, and then 1 plus 1 should get us back to 2. And then what else we got here? We got 4 -2 plus 1. So that'd be 2, and then 2 plus 1, and it's going to be 3. So let's go plot those. 0, comma 3, 1, comma 2, 2, comma 1, 3, comma 2, so it's starting to go back up, and then 4, comma 3. There you go. Alright, since this is all kind of running together, I'm going to switch colors here. Alright, so domain just going to put a D for that. Domain, same thing, negative infinity to positive infinity. Range, this changes each time. Now it's starting at positive 1 and going up forever. So we're going to say the range is including 1, so we'll put a bracket, 1 to positive infinity. Okay, and let's see, x-intercepts. There are none. Doesn't ever cross the x-axis, so you can just put none for that. Y-intercept. This one only has one y-intercept. Usually they're only going to have one y-intercept. And that is at 0, 3. Okay, the axis of symmetry, usually you're going to see that abbreviated as AOS. So I'm going to abbreviate that. Axis of symmetry, where is it symmetrical on both sides? Notice it always goes through the vertex. So that's going to go through the vertex value of 2 right there, or through x equals 2 right here on your line. And then last but not least, oh yeah, vertex. Vertex is at 2, 1. Right there, that is that lowest point where it turns around. Okay, so those are a couple of good examples right there. Yeah, so that's that. Let's look here at C. Notice this one has a negative out in front. And instead of making a full table, I also want to show you guys how to do this in the graphing calculator. Sometimes we as math teachers kind of, get excited to do all the mathy part, like in our head and stuff, but sometimes it's good to know how to use your graphing calculator for this. So I'm going to pull this to the side here a little bit. Let's see. Yeah, I think we can still kind of see it there. So I'm going to type this in here. Now, as far as like actually typing in an absolute value, most calculators don't have those symbols in there. So what we're going to do like absolute value of something is you hit the math button and then you scroll to the right hand side, scroll over here to number, and then ABS is absolute value. And oh, actually, so it does make it look like that. So you can put whatever number you want in there. So like you can put like -6, and then it should say, oh, okay, the absolute value of -6 is 6. And the reason that's useful there, like we don't need absolute value, like we don't need that here in this function here. It can be helpful for graphing though. So I'm going to go here to y equals, I'm going to clear out that last graph that we had, that we did together. And it looks like over here we got negative and then absolute value of x. So I'm going to put negative. I'm going to hit math again. I'm going to scroll to number, ABS. There's absolute value. I'm going to put x. X is right here next to alpha. Press the arrow to get out of the bars right there. So now we're outside the bars, and then we'll hit +1. Then we'll take a gander at the graph. Okay, so notice this one here. This one's a little different here. It's upside down. And one of the things, when we get more into this tomorrow, but one of the things that makes the graph go upside down here, as you might be able to guess, is that negative right there. That negative out in front flips the graph. So it's a reflection across your x-axis there. So yeah, there's that right there. Let's go ahead and I'm going to pull this down here for a second. Take a look at the table. If you hit second graph, you can take a look at the different table values. You can kind of scroll through them here. Good thing to know here is how to identify the vertex based off of your table. Sometimes that's a useful skill to know here. So if you look at all your y's, I try to find the y value to where, like, I try to find 2 of the same y values here. So notice here you got -1, 0, and then 1, 0. Like, notice both of the y values are 0 right there. So that means the vertex needs to be halfway between those 2 numbers there. So it's halfway between, so it's at 0, 1. Like, for example, if you had like -2 here and -2 here, your vertex needs to be halfway between those. So it's over here at 0, 1. So it's, sometimes you can use your table to help, get your vertex, labeled and everything here. So since we can see it over here on the right hand side, I'm going to pull this back up and we're going to copy over that table there to our graph. So point there, there. Usually about 5 points will do you pretty good with most teachers, but ask for clarification if you need. And then we can go get all the same stuff again. Domain was -infinity to positive infinity. That's pretty much going to be the domain on all these. Range is different here. So it starts it's coming from negative infinity, but then it ends up there at that positive 1. It doesn't go above 1 there. So it's kind of good to talk about this one here. X-intercepts, looks like you got 2 of them. You got -1, 0, and then you also have 1, 0. Okay, you got y-intercepts. Y-intercept over here on the y-axis there, that'll be 0, 1. What else do we got? Oh, axis of symmetry and also your vertex. Usually it's good to talk about the vertex first, but that's okay. Axis of symmetry actually goes through the x value of 0. So we're going to say x equals 0 for that. And then your vertex, I'm just going to label it with a V. The vertex is the point 0, 1. So sometimes there's a little bit of overlap, like your y-intercept happens to be your vertex as well. So we got all that going on there. So part D, we'll go ahead and do that as well here. We'll quickly use our graphing calculator to kind of blow through this here. So what do we have here? We had 1/2 out in front. 1 second. If you hit second delete, you can actually enter in before the bars right there. So I hit second delete, insert. It's that blue option there. So I'm going to put, I guess, 1 divided by 2. And then bars, and then this was -1 right here. And we can hit graph. Okay, good. That did what I wanted it there too. So notice this one here is a little bit, it's less steep, I guess, in this case here. So the points are a little bit different. So notice you got a bunch of 0.5s. I'm going to probably stay away from those and just use the whole number of versions there. So you got -4, 1, you got -2, 0, you got 0, -1. Then it looks like we go back up. You got 4, 1, you had 2, 0. So much flatter looking, but it's going up again. Okay, so domain, -infinity to infinity. Range, the lowest it goes is -1, so from -1 all the way up to infinity because it keeps going up forever. It's going slower, but it's still going up forever. X-intercepts, you got 2 of them again, 2, 0 and -2, 0. Y-intercept is going to be at 0, -1. Axis of symmetry happens to be x equals 0 again, and your vertex is at 0, -1. So there you go. Now some of you guys might be making some connections between some of the numbers and the graphs, and we're not focusing as much on that today, but like notice here we had the 1/2 out here in front. Notice here that the slope of the line is a little bit different here. Keyword slope, right? Remember slope, rise over run? That's got a connection there. And we'll get into all those different rules tomorrow. We'll do a couple more here of these different ones here, except we're going to be using these intervals here. And to speed it up here a little bit, because it does get a little bit repetitive, I'm going to go ahead and plot the points. So if you want to like pause it after I plot all the points, copy it over here, you can do that. But here's what this graph is going to look like. Just for time's sake, just kind of speeding this up. So you got these points. I'll make them a little bit bigger so you can see. All right, and now we're going to look at the max and min over this interval. So like going all the way to -2 right here, and then in between 1 right there. We're going to figure out what's the maximum and the minimum. Here, let me use a different color so that it's thick, I guess. So from -2 to +1. So in between this section here, what's the max and what's the minimum there? So you're looking for the highest y value and the lowest y value. There's a little review there. I think that's from Unit 1 there. So if you look, the highest this graph goes right here, looks like it's up there at +4. Okay, and then the lowest it goes, it's not this other endpoint here. The lowest the graph actually goes is down there where that vertex is. So that minimum is actually going to be 0 there. That's because that's the lowest y value. It goes up here to 4, but then down here to 0. And that's how you do your max and mins over given intervals. So some people, I think in the last unit, in Unit 1 or Topic 1, whatever you want to call it, most of you guys are just plugging in the endpoints of these. But this is where you got to be careful. Since we have these V-shaped graphs, sometimes that vertex is going to affect whether the point is the max or a minimum. So you have to look at the graphs to figure these ones out. So let's see, is there anything else we need to do? I think that's it. So graph using a table, I'm kind of speeding that up. Here's what this one's going to be right here. It's left 1 and down 2. That's where the vertex is right there. And then nothing's going on weird with the slopes. So plot all those points there. And then going up forever and then going left forever. Okay. So the interval that we are looking for here is between -3 and 2. So here's -3 on the x-axis there. Didn't do it perfect, but whatever. There we go. And then +2. Let's see if I can get that one straight. Good enough. Okay, so the maximum between this interval here, the highest the graph goes, like so just this section right here. It's kind of like a little check there. The highest that graph goes right there, looks like it's at +1 there. Okay, and the lowest it goes is down here at -2, I guess. So we'll say the min is -2. And there you go. So it's how high and how low. If you want to draw that little box there, maybe that kind of helps you with the max and mins. So that'll be good. Okay, let's do 2 more of these, and I think that's actually it for the lesson. Yeah, 2 more. Okay, next one here, you got absolute value of x -4, so that this is what this one will look like. And I'll show you all the rules tomorrow, I guess, on how to quickly graph these. Show you the cheat codes, I guess, for that. So, alright, what interval are we here? Between -3 and +2. So I think that's actually the same interval as the last one. Oh, no, didn't want to do that. Let's start from the top, I guess, there. So it's kind of like same idea here. It's kind of looking like a little check here. And yeah, so we are looking for the highest value for that. The maximum looks like in that interval there, the tallest it goes between that interval is at -1, and then the minimum of that interval, the lowest it goes, is at -4. And that is it on that one. And I guess we got one more here. Let's see what's going on with this graph here. X -3 inside the bars. So that's actually over here to the right. Nothing weird's going on with the slope. And going left and right forever. And then let's see here, the given interval we got from -2, so actually like kind of over here near the top of the graph right there. And then +4. Okay, so the max in that given interval, remember between these right here, the tallest that graph goes is right there at that point. And remember y value, so that is +5 that appears. And the minimum is the lowest that graph goes right there, so that'll be at 0 actually. So from 5 to 0. And I believe that is it here for today.